Hello, my name is Dhruv Arun from the FTC team Helix Hackers. Welcome to the Onshape Tutorials Chapter 1, Part Studios. First off, on the objective. By the end of today's lesson, you should be able to create and extrude defined sketches. First, we're going to get set up, then we're going to learn about sketches, then extrudes. So, you should be in Onshape. First off, create a document and name it to whatever you want. I'll be naming it Part Studios because that's the name of today's lesson. Let's talk about what a sketch is. A sketch is a 2D outline that you can apply features to create into a solid part. All parts start with a sketch, but to draw the sketch, you need a plane to sketch on. An example of a sketch is simply a box. So as you can see, I first off select a plane that I want to sketch on. It starts off with 3 default planes, front, right, and top. I'll select top for now. And then an example is just a box. That is a sketch. Now let's talk about different types of shapes that you can create with sketches. The first one is a line. The first click of a line defines one point. The second click of a line defines a second point. And in a rectangle, there are 2 main types of rectangles, corner rectangle and center point rectangle. In a corner rectangle, the first click defines one corner of the rectangle, and the second click defines the other corner. In the center point rectangle, the first click defines the center of the rectangle, and the second click defines one of the corners of the rectangle. And there are 2 main types of circles that you should be using. The first one is a center point circle. In a center point circle, the first click defines the center, and the second click defines one point on the circle. The second type of circle is a 3-point circle. In a 3-point circle, you define 3 points, and these 3 points define the circle, as we know that 3 points in general define a circle. So 1 click, 2 click, 3 click, that defines a circle. So now that you've learned these concepts, let's move on to the checkpoint. So now you've learned lines, rectangles, and circles. You should make a rectangle inside of a circle, inside of a rectangle that all share a similar center. And as you can see, this bar right here is where we use the lines, squares, rectangles, and circles. Try that out and then we'll move on. Pause the video here. So the first thing you should notice here is that all 3 shapes share a center, so we should be using the center version of the squares, the rectangles, and the circles. So let's select the rectangle, select the origin as the center, then do the same thing for the circle. Do the same thing as for another rectangle. There you have it. You have a rectangle inside of a circle inside of a rectangle. Now let's talk about different types of constraints. So constraints allow you to define the position and length of different sketches on a plane. So the first constraint we'll be talking about is a dimension constraint. For this part, you can either create a new sketch or edit the existing sketch by double tapping on it. I'll just be creating a new sketch for the matter of organization. So I'll rename this old sketch to shapes, and I'll create a new sketch that will use the top plane. So as I said, the first constraint we'll be using is the dimension constraint. The dimension constraint allows you to define the length of any edge or circle or angle. So let's just create a rectangle here and define the side length of this rectangle to let's say 70 millimeters. And as you can see, this side length is now exactly 70 millimeters. I can't manually change it unless I double click on the dimension constraint and type in a new value. So next constraint that helps you define lengths is the equal constraint. The equal constraint allows you to set 2 different either edges or circles or literally any different types of sketches equal to each other. In this case, I'll be defining each of these 2 side lengths of a rectangle equal to each other. So now both side lengths of this rectangle are 80 millimeters, therefore it is now a square. The next constraint we'll be talking about is the coincident constraint. The coincident constraint allows you to define where on the plane the sketch will be. So it helps you with defining the position of a sketch. So if you press the arrow, you can find coincident right here. And to use coincident, you can click on any point on the sketch and then any point anywhere else, and they're mated to each other. So now this is fastened onto this point, thus it's coincident, and as you can see, the sketch has turned black. This is because we've defined all the positioning and the lengths and the dimensions of the sketch, meaning it cannot be changed unless you manually change the values. So we've basically fastened this sketch. This is normally what you want to see when you're designing parts, because this means it's nice and defined and there's no room for error. Okay, so now let's go on to the checkpoint. You've learned how to use the dimension tools, the equals tool, and the coincident tools. Your goal is to make both rectangles from the previous checkpoint into squares, and then make the inside square have a side length of 1 inch. Then attach the inside square to the circle using the coincident constraint, and a challenge would be to use the points feature to coincident the circle to the outside square. So just a reminder, these are where the constraints are located. Now pause this video and try it out for yourself. So the first thing we want to do is make both of the rectangles into squares using the equals constraint. Now let's constrain the inside square to the circle using the coincident constraint. And finally, let's define the square as a side length of 1 inch. So now time for the challenge. So the challenge was to constrain the outside square to the circle. So to do this, you need to use a point, as if you try to constrain the circle directly to the square, what happens is you can't constrain two curves of a different type. So you'd need to use a point, and this point would have to be directly above the origin, otherwise this would happen. As you can see, even though the square is constrained to the circle, it can still move around because the point is able to move around. So here we'd use the vertical constraint on these 2 points. And now the outside square is perfectly constrained to the circle. The next concept is line constraints. So there are 4 main different types of line constraints. The first type of line constraints is the perpendicular constraint, which does exactly what you think it would. It makes 2 different lines perpendicular. So let's go ahead and select the perpendicular line constraint. Select these 2 lines. They're now perpendicular. The next one is parallel. So let's see what happens when I try to make these 2 lines parallel to each other. Obviously it turns out red because you can't have 2 lines that are both perpendicular and parallel to each other. So we need to press on the perpendicular mate and delete that. Now both lines are parallel to each other. The next constraint is the horizontal constraint. Basically what it does is it makes a line horizontal in terms of the planes. So horizontal is just like this. So if we select the horizontal constraint, it makes it 90 degrees with it makes it parallel to the front plane. However, there's a much easier way to make the horizontal line horizontal while drawing it. So while you're doing it, you will see this yellow dash that comes up, and if you let go while the yellow dash is appearing, then it automatically puts a horizontal constraint on it. It's the same thing with a vertical constraint. You could go ahead and make a line and put the vertical constraint on it, or you can just straight up place it while the yellow dash is there. Now onto the Part Studio's checkpoint for line constraints. So you've learned how to use perpendicular constraints, parallel constraints, horizontal constraints, and vertical constraints. You need to try and make a square only using lines and constraints. You're not allowed to use the rectangle tool or you're not allowed to use the rectangle tools. You only have to use lines and constraints, and inscribe the square inside of a triangle. You're allowed to use the equal constraint to make the actual lines into a square. And just as a reminder, these are where the line constraints are located. Pause the video here and good luck. So for this checkpoint, let's start off by creating a sketch. Select the top plane and create 4 lines. We can actually use the yellow dashes to make this line vertical, this line horizontal, this line vertical, and this line also horizontal. But now, let's make all 4 sides equal to each other. We have now successfully made a square using only lines. So, the next part is to inscribe the square into a triangle. So, let's actually try and create the triangle separately first. As you can see, the horizontal, the base of the triangle is actually horizontal as the yellow dashes appeared. So now let's make all 4 sides equal to each other. Sorry, all 3 sides. And now let's constrain this triangle to this square using the coincident constraint. Now we have inscribed the square into a triangle. Now that we've actually created sketches, we need to turn these sketches into parts. So to do this, we'll be using the extrude tool. So the extrude tool takes a closed shape and stretches the shape. So it uses it defines a depth. And for example, say I had this rectangle. If I extruded this, it would turn into a rectangular prism with the same this as the bottom face, and we define the depth or the height. So let's select the extrude tool, which is right next to the sketch tool, and select the rectangle as the face that we'll be extruding. As you can see, it's stretched it out and it now has a depth, and the sketch is now a 3D part. We can define the depth to whatever we want it to be. And for now, the only settings we'll be using are the new setting, blind, and the solid settings. Another part of the extrude is the arrow. The arrow defines which direction you're extruding the sketch in. If I press this arrow, it extrudes it into the opposite direction. So this will be useful for when you're doing extrusions in specified places and you want it to be in a specified direction. For now, just have it pointing upwards. Let's now move on to the checkpoint for extrusions. So you've now learned how to use the extrude tool. You know how to change the direction and create a new part. So you should make sure to have extruded at least one of your sketches, and a challenge would be to make 2 separate intersecting circles and extrude them each individually. See what happens when you try to extrude the second circle. And just as a reminder, this is where the extrude tool is located. Pause the video here and good luck. So I've just explained how to actually extrude the sketches, so let's work on the challenge. So the challenge is to create 2 circles and extrude them individually. So let's see what happens. So let's create a sketch. 2 separate circles that intersect, right? And extrude them individually. So let's select the extrude tool. First select this circle. As you can see, they intersect each other, so a new cross section appears. So we'll have to select both of these cross sections to extrude this circle. And when you extrude a sketch, the sketch is hid. So we have to press this eyeball next to the sketch to show it again. And now let's extrude the second circle. Okay, as you can see, we've extruded the second circle, and it automatically switches to the add part of the extrude instead of new. This is because they're intersecting, so instead of creating a new part entirely, what we're doing is adding to this part. We're extruding a new sketch, or a new part of the sketch, and adding this part. So we're building on top of the original part. So now we just have one large merged part that is composed of 2 different circles that are both intersecting. To create 4 cylinders, we first need to create 4 circles that are equally distant from each other. So let's go ahead and sketch. And so we need these 4 circles equally distant from each other. So to do this, I'm actually going to first create a square. And now we have 4 points that are all equally distant from each other. You might be able to see where this is going. We'll be using these points as the center of the circles. So now they're all equally distant from each other. Now we should just make these equal to each other. And we should make all of them have a diameter of exactly 25 millimeters. And now that they're all equal to each other, we change the diameter of one circle, all 4 of them are changed. So now let's extrude these circles to turn them into cylinders. Again, the square turns the circles into 2 separate cross sections, so we'll just select both cross sections to extrude the circles. Okay, so now we have 4 equally distant cylinders. And let's show the sketch again. So conveniently, the same square that we use for positioning the cylinders can also be used as the rectangular prism that we need to extrude. So let's go ahead and select all cross sections of the rectangular prism, change the direction that we're extruding it, and press the check mark. So now we have completed the mini project. Now let's work on the challenge. So for the challenge, you can sketch on faces of extrusions. So as you can see, this rectangular prism has a face on top of it, and we can just select this instead of selecting a plane. So now we're sketching on top of here, and we need to create a circle that's perfectly centered. Well, conveniently, we have this point right here. It's the center of the center point rectangle. So we can just go ahead, place the circle, coincident that point to this point. Now it's perfectly centered. You can press check mark, and you can extrude that circle. And there you have it. You have completed the mini project, and that concludes today's video. Thank you. It's time to apply what you have learned today into a mini project. So you've learned how to use sketches, including shapes, constraints, and line constraints, and you've learned how to use extrusions. Your mini project is to create 4 long cylinders with diameters of 25 millimeters that are equally distanced from each other. Create a rectangular prism on top connecting the 4 cylinders. So the most optimal way to do this is by only using 3 features. And a challenge would be to create another cylinder centered on top of the rectangular prism. Good luck. To create 4 cylinders, we first need to create 4 circles that are equally distant from each other. So let's go ahead and sketch. And so we need these 4 circles equally distant from each other. So to do this, I'm actually going to first create a square. And now we have 4 points that are all equally distant from each other. You might be able to see where this is going. We'll be using these points as the center of the circles. So now they're all equally distant from each other. Now we should just make these equal to each other. And we should make all of them have a diameter of exactly 25 millimeters. And now that they're all equal to each other, we change the diameter of one circle, all 4 of them are changed. So now let's extrude these circles to turn them into cylinders. Again, the square turns the circles into 2 separate cross sections, so we'll just select both cross sections to extrude the circles. Okay, so now we have 4 equally distant cylinders. And let's show the sketch again. So conveniently, the same square that we use for positioning the cylinders can also be used as the rectangular prism that we need to extrude. So let's go ahead and select all cross sections of the rectangular prism, change the direction that we're extruding it, and press the check mark. So now we have completed the mini project. Now let's work on the challenge. So for the challenge, you can sketch on faces of extrusions. So as you can see, this rectangular prism has a face on top of it, and we can just select this instead of selecting the plane. So now we're sketching on top of here, and we need to create a circle that's perfectly centered. Well, conveniently, we have this point right here. It's the center of the center point rectangle. So we can just go ahead, place the circle, coincident that point to this point. Now it's perfectly centered. You can press check mark, and you can extrude that circle. And there you have it. You have completed the mini project, and that concludes today's video. Thank you.